Happy, what is today? Wednesday, everyone. Hope that you're having a good day. If it's first or second period, hope your day gets started off on the right track. This is going to be a quick note day because you really need time with your calculator, and the note sheet actually itself is quite self-explanatory. So here's what I'm going to do. I'm going to show you guys something, and then after I show you, you're going to look at your notes and understand how matrices and your calculator can save the day. So I'm going to show you guys, first of all, how to solve this system of equations um, algebraically. And like I said a second ago, um, once you understand how matrices can be used to solve systems of equations, you're going to absolutely um, love it, and you'll never use the algebraic way, I promise you. So let me show you this. The first thing you have to do is when you have something like this where it's three equations, obviously it has three variables, and if I want to solve it, I've got to get it down to where I can solve for a single variable. So for example, what we do is we label these. So like this is A, this is B equation, this is C. What we have to do is we've got to utilize two equations at once in order to actually get rid of a variable. Then you got to take the result of those to get rid of the other variable, which will allow you to solve for that third and final variable. Then you can just go back and plug those all in. So it's wild. I mean, it's really crazy. So let me show you what I mean. I want you guys to notice right off the bat how these A and B both have a positive and a negative Z, which will naturally cancel each other out. So we're going to take the A equation, x plus y minus z equals 6, and we're going to take the B equation, 2x plus 3y plus z equals 9, and we're going to combine those, which will allow your z's to cancel. Now, with everything else, you just combine them the way you see them. Look, that's positive 1x plus 2x, that's 3x. Then you've got positive 1y plus 3y, that's positive 4y. The z's are gone, and then 6 plus 9 is 15. And we're going to call this D, okay? This is the D equation. It's new. It's new. Now, we've got to do the same thing, but here's the deal. I can't use A and B again because I just used it. Now, I could use A and C, or I can use B and C. But I want to use those two in order to get rid of the same variable. So since this A is negative Z and this C is positive 2Z, I'm going to use A and C. Now, I can't use A and C the way they are because negative 1Z and positive 2Z won't cancel out. But you know what I can do? I can multiply this A right here. I can multiply that whole thing by 2. So I'm actually going to do 2A, and then I'm going to use C. Now, if I'm going to do 2A, I've got to multiply the entire thing by 2. So here's how I do that. What is 2 times x? 2x. What is 2 times y? Positive 2y. What is 2 times negative z? Negative 2z. And that equals, what's 2 times 6? That's 12. But now that I've done that to this equation, I can use this one the way it is. So I'm going to use C just the way it is. 4x minus 5y plus 2z equals negative 15. So I'm going to combine these now, and in doing so, look, z cancels out on these as well. So that leaves me over here with 2x plus 4x, 6x, 2y minus 5y minus 3y, and then the z's cancel, which leaves me finally with 12 minus 15, negative 3. And we're going to call this E. So I want you to notice something about these two new equations. D and E now only have x and y. So what we're going to do is we're going to use D and E to get rid of one of the other variables, okay? So really, it's your call which one you would get rid of. when I look at this, I notice that this D has a 3x. This has a 6x. I can change this one right here real simply to be the opposite of positive 6x. I can change it to be a negative 6x. Now think about it. What would I have to do to 3x to make it negative 6x? I would have to multiply by negative 2. So that's exactly what I'm going to do. I'm going to take the entire D equation and multiply it by negative 2. Now, again, I have to do nothing to E. It's going to be perfect the way that it is. So here we go. We're going to multiply the entire D equation by negative 2. Ready? So what's negative 2 times 3x? Negative 6x. What's negative 2 times positive 4y? Negative 8y. Equals, what's negative 2 times 15? Negative 30. But now I can bring the E equation over just like I see it. 6x minus 3y equals negative 3. Now, why would I do that? Okay, because now look at what else will cancel. Now, negative 6x and positive 6x will cancel, leaving me with one final variable, y. Negative 8y minus 3y is negative 11y. And on the right side, negative 30 minus 3 is negative 33. If I divide by negative 11, negative 33 divided by negative 11 is positive 3. My y value equals positive 3. Now, how does that allow me to solve for the rest of them? Well, I can go back to D or E now. It doesn't matter which one you pick, D or E, and I can solve for my x because I can plug that 3 into it. So which one you want to go with doesn't matter. I'm going to go with E, and I'm going to go plug that in. Okay, so I'm going to use a different color. I'm going to go 6x minus 3 times 3, that's the value of y for this equation, equals negative 3. Now that's 6x minus 9 equals negative 3. I'm going to add 9. What's negative 3 plus 9? 6. I'm going to divide by 6, so x equals 1. So I now have x and y. So now I want to find z. So I'm going to go back to one of the original ones because it has x, y, and z in it. And I'm going to plug in the two that I know, x and y, to find z. Now, when I look at these, again, it doesn't matter which one you choose. But to me, the one that's easier is the one that has z just alone. So I'm going to go back to that equation, and I'm going to go, okay, 2 times, whoops, I have to get a pen. I'm going to go 2 times x, which we found to be 1, plus 3 times y, which we found over here to be a 3, plus z equals 9. Now, what is 2 times 1? That's 2. What's 3 times 3? That's 9, right? So 2 plus 9 is 11, plus z equals 9. So the last thing I'm going to do to get z alone is subtract 11. 9 minus 11 is negative 2. So my z value is negative 2. So crazy, but listen, the solution to this system of equation is 1, y, that was x, 3, y, that was the y value, negative 2, that was the z value. 3 variables, 3 solutions. Now, here's the point. Your calculator will do all of that for you. It's as simple as using matrices in order to solve. This note sheet does a step-by-step on what you need to do in order to solve this system of equations using your graphing calculator. What I want you to do is I want you to try this on your own and follow all the steps, and you'll see that you get the same answer. You have another couple of examples where they give you word problems where it's the same concept as far as what happens with your systems of equations. I want you to try to figure those out. And then your assignment will be these 6 problems. Okay? Listen, a little bit more challenging than usual because I'm not going to work through these examples. You're going to learn how to do this in your graphing calculator. You're going to see that it's way better than having to do this right here. This is crazy. This is how you solve a system of equations with 3 variables algebraically. You don't want to do this. You want to be able to use your calculator. You want to use matrices, which we've been talking about it, in order to solve. This is called augmented matrices. That's kind of what today's lesson is about. So read the instructions, follow all the key presses that are in here. That's your job to read through and practice this. We'll clean it up tomorrow, but I will be back with you. All right? Have fun. Figure it out.